Hello, I'm Jocelyn Bell Burnell. I'm in Edinburgh. I'm President of the Royal Society of Edinburgh, based in George Street. They very rarely produce light. That's the first thing to say. A few of them do. Most of them produce radio waves, and the radio waves swing round the sky as the star spins, a bit like a lighthouse sweeps a beam of light around. And every time the beam flashes across the Earth, we see or hear a pulse of radio waves. So if you listen, as you would listen to a radio, you hear pulse, 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 quite regularly and maybe faster than that. They are basically radio pulses. Light is both a particle and a wave. Sometimes it behaves as a wave, sometimes it behaves as a particle. As a rough rule of thumb, it travels as a wave, but when it bumps into something, interacts, enters your eye, it behaves like a particle. I tend not to say what it is, I tend to say how it behaves, because that's what we see as scientists. Mining a neutron star would be very interesting. I think we need to think a little bit about what we're doing and how. First of all, the surface of the star is probably as strong as steel. They're very unusual stars. So you have to think how you don't mine it, do you? You cut into it or something like that. Having got a chunk of it, you also need to know that a teaspoonful of typical neutron star material weighs the same as the 7 billion people here on Earth. So you don't really handle it in any sense. It's seriously heavy. I don't think it's got interesting minerals or things like that in it. So it's not useful in the way you could mine other astronomical bodies, some other astronomical bodies. But it's certainly very interesting for its physics because it's so dense, so heavy, so compact.
So contrasting to what a lot of people think that scientists do, I don't typically spend most of my time in a lab coat, kind of looking at things down a microscope.